podcast people. Welcome to Climate and Conservation Conversations, C3, if you will. The first full episode, I would like to talk about the elephant in the room. And by room, I mean planet Earth, and by elephant, I mean climate change. It fills up the whole room, quite frankly. So this episode is going to cover one of the biggest misconceptions about climate change. There's this famous line, and it's floated around for a number of years now. You've probably heard it, or some iteration of it. And it goes a little something like this. If there's global warming, why is it snowing? Yeah, This sentiment was brought to you by U.S. Oklahoma Rep. Inhofe, who brought a snowball to the floor as evidence that global warming is a hoax. He, however, is a very outspoken climate denialist who knows absolutely nothing about what he's saying. I bet he actually does understand it, but this is a rant for another day. So I guess that seems like a good argument, but only if you know nothing about science or the difference between climate and weather, and there is a big difference between them. But if you don't know that much about it and you want to know more, ask a scientist. I promise you they are happy to talk your ear off about their research. You can send them an email, you can find their social medias and hit them up, or go talk to your local meteorologist. They will tell you all about it, and they are very chatty people. The argument really isn't the whole I gotcha moment that a lot of people think it is. If you look outside and it's snowing, that is a weather event, which is not the same as climate. And that is exactly what brings us to the topic for the episode, the difference between climate change, weather, and why they seem to be used so interchangeably. But if you don't know the difference between the two, I guess you would use them interchangeably? Or you do use them interchangeably when you're purposely trying to muddy the water to confuse people for your own personal gain, and once again, that is a rant for another day. At the time of recording this, we are nearing the end of winter. And where I live, there has been record and near record breaking temperatures, which makes the end of winter feel very, very weird. If I didn't know any better, I would think it's mid to late May right now. It's bonkers how incredibly warm, beautiful, and sunny it is. I'm enjoying the blue skies though, because I need a break from the never-ending clouds living in the Northwest. But it's weird. Not exactly a fan of what this means for our summers. But anyway, back to the topic at hand. At the basic level, climate change refers to long-term trends in a region, and weather is a short-term atmospheric trend. A region may be steadily increasing in overall temperature, but it can still snow in the winter. Or conversely, a place may be experiencing long-term drought that can still have rain. These are a totally normal thing. Weather is what you're seeing outside if you look at the window right now. Climate is a very long period of time. All right, with all of that being said, let's talk what climate is. Climate is a region that's defined by its weather averaged over a long period of time, and we're talking like 30 years minimum and longer. The longer, the better. And it's looking at things like humidity, precipitation, which might be rain, snow, sleet, whatever, sun, wind, that sort of thing. These long trends let us know if we could expect hotter summers, mellower winters. Will we have dry summer, wet spring? What is it looking like in the future? But what you may not know is there's microclimates in a region too. And it's exactly what you might think, micro being small. So a microclimate is like a little pocket in a region that experiences weather differently than the other little pockets next to it. So I live in a region that's really mountainous, but there's also deeper valleys along the riverbanks. Personally, I live on top of a big hill in the area, and it's about 500 feet or so higher than the downtown area. So when it comes to climate weather, we experience it a little bit different up here. Oftentimes, it will be full-blown snowing at my place, but friends or family elsewhere in the city aren't seeing snow at all. They might not even be experiencing rain. It might just be a little cloudy for them. So it kind of makes planning your day a little tricky. I mean, there's plenty of times where I've gotten up in the morning to see snow everywhere, thinking, oh, well, maybe I'm not going to go anywhere. And then I get, a quarter way down the hill and it stopped. It's interesting how that works out. Anyway, it's just something to point out. But when you check the weather forecast, It's giving you the average stations in your area, maybe even weather satellites. So it's not just like me, the weather station up by me is going to be a little bit different than the weather station down in the valley. Something to consider. Also, very useful to go get an indoor-outdoor thermometer. I want to explain to you how scientists and data folks like myself go about looking at these numbers. I won't bore you with the nitty-gritty of the math or anything like that, but just a good general understanding will help you differentiate between good and bad science being reported. And not just that, but if you encounter, which you absolutely will, somebody online who's going to say something as idiotic as 100% of scientists have been wrong since the 50s, which makes absolutely no sense, but they think they're right, and this will let you know that obviously that is a very bad number. So if you're not quite sure how a trend works, think of it like this. You have a piece of paper in front of you, and you're drawing little squiggles up and down from left to right. But as you start moving right, you go up and up and up towards the right top of your paper. So even though there's peaks and valleys as you're going up and down, the overall direction of your squiggles is going upward. Or like you're driving up a mountain. The road might dip down a little bit, but overall you're still in an upward trajectory. That's your underlying trend. Sometimes this can be really hard to see in data sets and requires a lot of data to analyze. If you have too short of a time frame, you're not going to see these long-term trends like this, or things like seasonality, which is also very important. As you can imagine, seasonality is like seasons. It's something repetitive in time. It's cyclical. It's a cycle. Spring, summer, autumn, winter. Those are seasons that we are familiar with. And the same sort of thing will show up in our data. Using some different math techniques, you're able to look at that trend under those seasons. So without getting into algebra or calculus, that's essentially the gist of what trends and seasonality means when we're looking at data. So, back to why trends were brought up. Scientists look for historical climate data by analyzing objects like ice cores. And I'm sure you're thinking, okay, cool. How exactly does ice help us? And it's the air bubbles trapped in the ice. Those little air bubbles help us know what greenhouse gas levels were like in the past and how it changed over time. When the ice core comes out, if you look at it, it has a bunch of really thin layers in it, and that's giving us our length of time. Another method is tree rings. How wide or skinny the rings are, what their chemical composition is, that sort of thing. And there is a difference in the types of trees and how the tree rings work. So we have trees that depend more on temperature during the growing season. Those will have narrow rings during cold periods and wider rings during warm periods. And then we have trees that depend more on moisture during the growing season, and those will have wider rings during rainy periods and narrower rings during dry periods, which makes sense when you think about how objects interact with warmth and moisture. Tend to expand like a marshmallow, might shrivel out like drought, that sort of thing. And there's also coral, or coral skeletons. And that's very similar to trees in that they have growth rings that can tell us about past climate conditions. And you might not know, coral is actually a living organism, much like a tree is. There's also fossilized plants that can be found in layers of the earth, like palms or ferns. And then, a layer above that, it will be grasses, which tells us that there's a shift in the climate. Palms and ferns are subtropical type plants, whereas grasses are going to be growing more in the scablands. At this point, you might be asking yourself how this relates to climate trends. These methods of looking back in time give a substantial amount of data, to the point that we need supercomputers to look at this. We have ice cores that go back 800,000 years, which is a very, very long time. And then we obviously have fossils and sediment layers that go back millions of years. All of this together gives us a very good idea of what happened in the past with Earth, which then all builds up to something called forecasting, which you might, you watch the news, you hear the weatherman, weatherwoman, weather person, whoever say, well, look at your 10-day forecast. So the forecast is using past data fitted in a model. And the model is saying, based on the past data, this is what it goes up, it goes down. This is what we can expect. So it takes that line, essentially, and then it just projects it further out in time. So the further out you project, the more error prone it will be. But if you have a really good model, your 10-day forecast should be pretty good. That is on a shorter time scale, though. A climate model is going back, and you've guessed it, hundreds of thousands or millions of years. We're going back really, really far in time to understand these things and to look at that and be able to push forward. That is forecasting, using what we know in the past to tell us what will happen in the future. The difference is anthropomorphic climate change is what people are talking about when we say climate change is impacting our way of life. It has changed in the past. Everybody knows this. Nobody's arguing about that. It's the fact that it is changing at a different rate than it should have if we continued with the past data. There's something in math called causal inference. So we can say, if you have this past data and it kept going, what would it look like? But if you have that past data and there's an event that happens and it's changed after that. So you want to know what it would look like without that event happening. Our event is the Industrial Revolution. That's our Kickstarter for everything. I hope by now you're able to understand that weather is a daily phenomenon, a weekly phenomenon is an atmospheric phenomenon in the present. Climate is something that's happened over a very, very long time. We use our extreme amount of data from all over the world to look at trends, seasonality, use that data to push forward and forecast to see what would happen in the future. And now hopefully you know the difference between what the climate should be and then why everybody, or should everybody, be upset about the human impact that is happening right now. Climate is complex. And if someone doesn't take the time to break it down into the simplest concepts without getting very nitty-gritty in the math or the science with it, it's hard to let people know what they're hearing in the news. Because depending where you get your news, they might report things differently. But I hope at the bare minimum, you're able to think, wow, this is very complex, but it can be broken down in simple terms. Math doesn't have to be the scary thing. Physics doesn't have to be the scary thing, because underneath all of this, it's math that explains how models work. There's physics to explain all the different phenomena that are happening. All of these are built on very complicated principles, but they can be explained in a simple way. Going forward, if someone tells you that climate change isn't real, it's not happening, I hope you're able to understand that it is something that's very real. It's happened in the past, it will happen in the future, but that what we are experiencing now is the human impact on climate change that's been happening for over a century. And what that is going to do to our future is what we are still trying to find out. But what we can say is the impact that humans have had on top of the natural cycle is projecting us to an unfavorable future. All right, everybody. I hope this was a very interesting and insightful topic for you. It helps you understand the difference between the two. I look forward to telling you more about all the different niche aspects that go into climate change and talking about conservation and how often climate and conservation go hand in hand. Thank you for listening, and until next time.